Hello everyone, welcome back to the channel. Today we are going to look into one of the most frequently asked JavaStream interview topic, you would say. So why Java introduced primitive streams? When we say primitive streams, there are three primitive streams: IntStream, then we have LongStream, and then we have DoubleStream. So why were these introduced when we already have stream of T, right? What was the need actually? So this is something that we'll explore, and by the end of this video, you would be basically you would basically know everything about the reason or the reasoning behind this. Now let's take this example. What I'll do is I'll create a stream of integer. It's an integer stream, and what I'll do is I'll just copy this dot off and convert this into string. So what this does basically, this is the list collection, and when I do dot stream, it returns the stream of integer, or basically the stream class. It accepts any kind of data type basically, or type. So since the list is of integer, so we get stream of integer. Now this is fine. Now if we have stream of integer, say I want to do sum of all these elements, right? So if you look here, we don't have any method, a direct method you could say, where I can do sum or those kind of, right? There is count and everything, but sum etc are not present here in the direct string, and it is not recommended as well. So even if you do it basically internally, even if I do this, what will happen internally? Let's understand this. Just run this part. Okay, count is 3. So what happens basically? See, I got the integer. Okay, then that integer internally, Java what it does basically, it will convert that into primitive value. Primitive value, and then I would do my count etc. Whatever is the operation. So here what I'm doing is we are basically unboxing the object to primitive type. So there is this option, there is this operation basically of boxing and unboxing. So boxing is basically converting your primitive to object, or basically wrapper class like integer. And what is unboxing? Unboxing is basically opposite of this. So wrapper to primitive, right? And what are the primitive data types? Int, char, long, boolean. So these are our primitive data types. See, these primitive data types, they don't have any their own operations, right? Like say if I make int x equals 3. Now can I do x dot compare or something, or any operations on this x? It's just a simple primitive value. It's not an object. So the wrapper classes like integer, they have their own methods, right? Like the integer will have two string etc. So this boxing and unboxing happens internally, right? So when we call this internally, this boxing and unboxing happens. So to avoid that, so, and to make it faster basically, see, boxing and unboxing will add some latency, right? So to avoid that, so Java created a primitive integer stream in long stream and double stream, or basically primitive stream. Now let's look at the same example with integer stream. See what happens here. And I call this, I create in stream. I'll just add 10, 20, 30 here, same values. When I do int string, it gives me option of sum, count, etc. Since this is primitive string, right? There will be no boxing and unboxing. So there is no conversion which is happening. It is directly going to process these methods actually. Dot sum, dot count, all those stuff. Max, mean. So that's the advantage here. And that is why it becomes faster. Although you have options to actually convert this into, uh, say, if I want to convert this into string of integers, I can do that. I have that also option. I have that option. So hopefully you understood why primitive streams are required. So this was the reason why primitive strings are required. Now let's understand how this IntStream works and what are the various methods that IntStream provides. Let's start here. Let me comment this. Okay, so I have this IntStream. Let's start with IntStream.sub. Right. Why? If I just print this value, either I got 60. Let's find the maximum value. Yeah, I got this. Stream has already been operated upon or closed. Like I told you, once stream is executed, it is closed, right? You cannot reuse it. You cannot reopen it. So I need to again restart the stream. So just keep that in mind. Here I'll have to create a new stream. I'll make stream 1. And it is returning optional here. I'll just use it as int. I got the maximum value is 30. Similarly, we can get the minimum value. But again, I have to make sure that the stream is reopened again or created again. I got the minimum. Now let's take example of count. See, these are terminal operations. And that is why we have to actually recreate the streams. Okay, the count is 3. So these are the basic methods that IntStream provides. Now you can use IntStream for generating values. Now there are some static methods of IntStream. Let's check that out. IntStream.off, we have already used it. Now there is IntStream.builder. Now what this IntStream builder is, okay, so we get IntStream.builder, this object, and when I use this, when I don't know the values actually in advance, when I don't know the values in advance, I would use the IntStream builder. So here I can just add values, say 100, IntStream builder dot add 200, let me add one more, 300. Now once the values are added, you can create IntStream 4 and your IntStream builder dot build will actually return your IntStream. Now you can call this to do whatever operations we want. I just want to print the values. Let's see the output. I got the values 100, 200, and 300. So this is my builder class. So you can use builder as well when you are not knowing the values in advance. Now let's look at the other range. Say I want to generate values between 1 and 5. So in that case, I can use range. So these are generators basically. Now let's see the output. So 1, 2, 3, 4, 5. As you can see, 6 is excluded. So the end value is excluded. Let's keep this in mind for range. And in case of, if you want the range to be included, in that case, there is option of range closed. I will use 11 to 16. Here end value is included. As you can see, 11, 12, 13, 14, 16. So this is body range. You can generate values. And you can even create the string if you want to return basically eh, empty string instead of null. So in that case, you would use IntStream.empty. Let's understand one more method of IntStream, static method of IntStream. This is generate method. This is to generate infinite data. Generate infinite data. So you can use generate, and the input to generate is an int supplier. Basically, it's a supplier. Okay, keep that in mind. Okay, I just return some value 100. And if I leave this, this is an intermediate operation. Now this is terminal operation. Once I do that, I'll run this. As you can see, it has created infinite data, basically a string basically. You can even generate random data, something like this. Let's try this out. We call random.nextInt 100. This time we will add a limit actually. Let's limit 10. Okay. So we'll generate 10 values. As you can see, it has generated 10 random values. Okay, so this is how you can generate the values. So we have this range closed, then we have this infinite string. These are the advantages that you get with the IntStream. Then iterate actually. So we see it actually, the first thing. So basically we start with 1, and then there is a unary operator basically, or you could say unary function. What it will do is, I will say n into 2. Okay, so it will iterate. It will start from 1, and it will multiply by 2 for the first value, and then keep on doing it till we stop it actually. So let's add limit of 10 and for each. If you don't put limit here, it will also become an infinite string. Now let's check the output. Let me give a section break. This is iterate. As you can see, it has generated 10 values. Started from 1. 1 into 2 is 2. Then it passed 2 here. 2 into 2 is 4. Then it passed 4. 4 into 2 is 8. Then 8 into 2 is 16. 16 to the 32. 32, 64. And in this way, it went till 512. And say suppose if I remove this, it is giving 0. This is an infinite string. Let's see. That is why we have to add limit. Now, suppose now iterate has another overloaded method actually. Here we can pass the condition as well. So you can stop when n is basically we are passing the predicate n is greater than 200. Now I don't need to specify limit. As you can see, now in this iterate, we have the seed value. It starts from 1, then the predicate. Okay, it will check the predicate and then the operation. So 1 is greater than 200. No, so it will continue. Let's check this output also. Iterate with predicate. So it is n less than 200. Over n less than 200, we have 1, 2, 4, 6, 8. It will continue till 128. And if you look here after that, it is 256, and 256 is less than 200. It's basically a positive condition. Till the condition is true, it will continue to iterate. Okay, so that's the iterate with predicate. Let me check. Concat is basically if I want to merge two streams actually. Let me add these two strings on it. We take 21 to 26. Yes. Then we have 31 to 36. If I do this, we'll check the output. In the concat, we have two streams 21 to 26 and 31 to 36. Here it is 21 to 25, 31 to 85. We got single stream. So that's the so concat basically. So I think these are the major static methods of IntStream that we have covered. Now for the other methods which are not static basically, which are stream methods. So we have a lot of methods here. So like you can find max, mean, sum, etc. that we have already done. Limit we have already used. So it is same. We will use map again. I create a new string here. In string 5. In string of we'll use range here. It's from 100 to 105. What I'll do is we map this, multiply this by 10. In string 5. We will print this value. It is multiplied by 10. So this is basically a transforming method. Basically, we are mapping, taking the value from the source and doing some transformation on top of that. That is map. And say suppose instead of map, I want to it is already sorted. I can convert it into double, or that is up to us. Let's into n and just print. Let's see the output. As you can see, it has converted into double. And you can also use as double string. You will get the same thing. What I had done above basically. When you use map, basically map to double, you can do some operations. You can transform it basically. That's the difference. And when you do as double string or as long string, it will convert the value to double or long. And here we transform and convert the transform value to double. That's the difference. And let's look at more examples. This is take while, right? So take while is till the condition is met, it will continue to show the data. Basically, there is a predicate condition. Okay. Now, what I want to check is if n is less than 103, then you display the data. As you can see, my stream has 100, 101, 102. Let me make it closed. Okay. So 100, 102, 100 till 105. And once this condition is met, it will stop. This is take while. And if we take the same example, and if we do drop while, if you do drop while, to close this screen. See what it does is basically as soon as the condition is not met, from there till the end of the stream, it will continue to process or basically execute the terminal operation. That's the drop file. And these are some of the widely used methods that we have. One more method widely used is filter that we all know. It's same like this one. The difference between take while and drop while and filter is when I say n is less than 103, or you could say, let me take some other example here. Create a new IntStream. I take this example 2, 4, 6, 8, 9, 10, 12, 11, whatever. Now what I'll do is I will check if this is an even number or not. If I do this and percentage 2 equal to 0, and then I use for each, it will only print even number. It will process string. It will process the complete string. So here you can look 2, 4, 6, 8, 10, 9 was filtered, 10, then 12, 11 was filtered. Now we will take the same example and let me create a new stream 7. And we will use Instead of filter, we'll use drop while. Or sorry, take while. Let's take while. See what happens. In case of take while, it will continue till the predicate condition is met. As soon as it fails, so it failed at 9, it stopped processing the stream. And let's take similar example for drop while. We'll take stream 8 and like, what happens basically in take while it showed up till 8. In case of filter, we saw that it processed all the elements. In case of drop while, it will ignore this. Whatever condition is true, it will be ignored. It will not be shown. And once the condition fails, it will not even run any predicate. From there till the end, it will directly print it. So that's your drop while. So just understand the difference between filter, take while, and drop while. These methods are actually available for all kinds of string. I just took the example of IntStream. So this is the details or the hands-on of IntStream. Similarly, you can try it for LongStream. It's very similar. It's just the primitive type is changing. There will be 10L, 20L, 30L. Rest everything is same. If you look at the methods, so we have builder method, iterate method, concat method, empty method, range close, etc. And same for the double stream. It's same, right? So this was all about the primitive streams. I have covered IntStream in detail. LongStream and DoubleStream are similar to IntStream. If you understand one of the streams, others are same as the other ones. Thank you so much.